Good morning, students. This lesson is of class 8th for the subject of physics. Topic: acceleration and retardation, which is covered in chapter 2, motion in one dimension, and is given on page number 32 of your physics textbook titled Concise Physics by Selena Publications. This lesson is sent to you on 26th April 2021. Children, before going to acceleration and retardation, there is one more important concept related to velocity of a body. Children, when a body moves in a circular motion, then its velocity at each point acts tangentially outward. Children, suppose if we just see figure number 1, if the particle is rotating in a circular motion, for example, the particle is going from A to B, B to C, and so on. Then the velocity, which is a vector quantity, it always acts tangent, tangentially outward. Now, what is tangent? Tangent is a line which just touches one point of a circle. It only touches the circle from a one point. So, when the particle is at A, this is the tangent. Suppose when the particle is at point B, this is the tangent. Point C, this is the tangent. Again D, the tangent will be in this direction. E, the tangent is in this direction. So children, what is tangent? A line touching the circle at a single point. Whenever the body is moving in a circular motion, then the velocity at each point acts tangentially but in an outward direction. You can see this as shown in figure number 1. All the velocity vectors are shown with a line acting outward. When the object reaches back to point A, it started from point A, moves in a circular motion, and reaches at point A. As we have done in our second PDF, when the particle starts from a point and after rotating, it returns back to its point, then the net displacement of the particle is zero. What is zero? Displacement of the body is zero. And if displacement is zero, velocity will also be zero. Why so? Because the formula of velocity was displacement upon time. What is velocity? Displacement upon time. So since velocity is zero, since displacement is zero, therefore velocity will also be zero. Now let us start with the word acceleration. Children, acceleration is defined as rate of change of velocity with time. Rate of change of velocity with time. And as discussed last time, the word rate represents division with respect to time. So rate of change of velocity means change of velocity. Rate means divided by time. So rate of change of velocity means final velocity. That means the velocity at the end minus initial velocity. That is velocity at the starting point divided by time interval. Children, for example, if a body is moving with the speed of 20 km per hour, and after a time of 2 hours, it gains a velocity of 80 km per hour. So the speed has increased within 2 hours. In such case, if we want to find acceleration, it will be velocity at the end. That means final velocity, which is represented by small v, minus initial velocity, that is represented by small u, whole divided by time t. So v is how much? In this case, v is 80 km per hour and u is 20 km per hour. So this becomes 80 minus 20 km per hour divided by time is 2 hours. So what is acceleration? 80 minus 20, that is 60 km per hour divided by 2 hours. We can write it as 30 km per hour square. Now children, I hope this is clear. Let us do one more question. Now try this question yourself. Initial velocity of a body is 15 meter per second. Initial velocity is 15 meters per second, and after a time of 20 seconds, the object is gaining the velocity of, suppose, 65 meters per second. You all are required to find the acceleration. So children, do this question yourself in your physics notebook. Initial velocity is 15, time is 20, final velocity is 65. You need to find acceleration. Children, don't write down direct answers. First step is you use the formula. Acceleration is equal to final velocity v minus initial velocity u divided by t time. Put the values. 65 minus 15 divided by 20. So what is 65 minus 15? What it will be? 65 minus 15 is 50 divided by 20. So children, this comes out to be 5 by 2, and you have to divide this 5 by 2. You are not supposed to keep the answers in fractions. So acceleration, if you divide 5 with 2, you get it as 2.5 meter per second square. I hope you all know how to divide and get the answer in decimals. You have to write down the denominator in the divisor and 5 will come in dividend. So 2 2s are 4. Put a subtraction sign. 5 minus 4, 1. Now put a sign of decimal. And when you are putting a decimal here, a 0 can be brought with 1 such that the number becomes 10. Now 2 5s are 10 and our answer remainder comes to be 0. So the acceleration in this case is 2.5 meter per second square. So I hope this is clear to all. This is the way we find acceleration. So children, now the SI unit of acceleration is meter per second square, while CGS unit for acceleration is centimeter per second square. So this was all about acceleration. whenever the speed is increasing, we say that the object is accelerating. Now comes the word retardation. Retardation. Children, negative acceleration is known as retardation. Negative acceleration. If your acceleration comes negative, it means retardation. It is also known as deceleration. And what do we mean by retardation? Children, it is rate of decrease of velocity. Acceleration was increase on velocity, and retardation is rate of decrease of velocity with time. Suppose the answer of acceleration of a body is coming to be -5 meters per second square. If acceleration of a body is -5, then we say that retardation of 5 meter per second square is occurring. Children, note that if this is minus, acceleration is minus, then it is termed as retardation. And no need to put the sign of retardation here. Only acceleration, negative acceleration in itself means retardation. So now there is a note for you all. If final velocity, that means end velocity, is greater than initial velocity, that is the starting velocity, then we will be having the case of acceleration and its value will come positive. But what happens if initial velocity is more? Children, if initial velocity is more than final velocity, then acceleration is said to be negative. For example, if initial velocity is 65 meters per second and within 5 seconds we are applying brakes such that the final velocity is 10 meters per second, then what will be the acceleration in this case? The body was moving with 65 meters per second and you are applying brakes to bring its speeds low. So it becomes 10 minus 65 divided by 5. 10 minus 65 is minus 55. Is it fine? Don't write 55 because 65 is big number and it is having a minus sign with it. So our acceleration here comes minus 55 by 5, that is minus 11 meter per second square. So our acceleration is coming to be minus 11 meter per second square. So what will be retardation? Retardation can be written as simple 11 meter per second square. So when we are writing retardation, we are not supposed to put a sign of minus. I hope this is clear. In this case, initial velocity was more as compared to final velocity. Now, see the diagram shown to you. Children, in this diagram, you can see a car which at 0 second was at 20 meters per second speed, and after 2 seconds, its speed has become 4. So earlier it was 20, now it is 4. So what is happening here? You must be applying brakes. You are decreasing the speed. That means, what are you doing? you are decelerating. So students, you can see in the calculation I have shown 4 minus 20, V minus U. So 4 minus 20 divided by time is 2 seconds. So that becomes minus 16 by 2, which is minus 8 meters per second square. And retardation can be written as simply 8 meters per second square. Students, now open page number 3. On page number 3, kindly see figure number 1. Now children, this thing you have to understand, that if the velocity and acceleration are in same direction, then we say that the car is speeding up. The car is speeding up means both velocity and acceleration are in same direction. But children, if velocity is in one direction and acceleration is in other direction, then we will say that the body is slowing down. So here the car is slowing down. So what we have to remember? Speeding up means both velocity and acceleration are in same direction. But if velocity and acceleration are in opposite direction, then the body will be slowing down. And that will be the case of retardation also. So children, let us learn uniform acceleration. The acceleration is said to be uniform or constant when equal changes in velocity take place in equal intervals of time. What is this? When velocity is changing, but in equal manner. For example, if an object increases its velocity by 6 meters per second in 2 seconds and further increases its velocity by 6 meters per second in further 2 seconds. Then what is happening here? After every 2 seconds, velocity is increased by 6 meters per second. So we can say that rate of increase in velocity is same, and same means constant or uniform. So it becomes an example of uniform acceleration. Children, uniform acceleration, you can see figure 2 also. I have shown you a car speeding up in a proper direction, in a particular straight direction. Originally its speed was 10, and after 5 seconds, its speed became 20 seconds. And again, after further 5 seconds, its speed becomes 30 meter per second. So what is occurring? After every 5 seconds, the speed is increased by a factor of 10 meters per second. So see case 1. If we see this case, initial velocity is 10, final is 20. Time is 5 seconds. So how to write down acceleration? V minus U by T. V is 20 minus 10 divided by 5. So 20 minus 10, 10 by 5. It comes out to be 2 meters per second square. So here our acceleration is 2 meter per second square. Now let us see second case. where I am taking 30 and 20. Children, in this case, 20 will be initial velocity while final will be 30. So find acceleration here. Acceleration will be 30 minus 20 upon again 5 seconds, because time in between the two cars is 5 seconds. So if you solve, your answer will again come 2 meters per second square. So what is occurring here? Each time the value of acceleration is coming same. So it is an example of uniform acceleration. Similarly, we are having variable acceleration. If change in velocity is not same, if change in velocity is not same in same intervals of time, then the acceleration is said to be variable. For example, the motion of a vehicle on a crowded road. Children, on a crowded road, you are not moving with same velocity. Your speed is continuously changing. So then you are moving with variable acceleration. Children, note that if velocity is uniform, that means if there is no change in velocity, then in that case acceleration is 0 meters per second square. It is very important concept. If there is no change in velocity, for example, if the body was moving with 30 meters per second and after a time of 20 seconds the body is still moving with 30 meters per second velocity, then acceleration will be v minus u by t, that is 30. V is 30 minus 30 upon 20. So 30 minus 30 is 0. And 0 divided by 20, 0. So if speed is constant, that means if velocity is uniform. Children, if uniform velocity, if there is no change in velocity, in that case we are having 0 acceleration. I hope this is clear. And such a motion is known as non-accelerated motion, since the acceleration of the body is 0. So children, I have given you some numericals which are solved in your PDF, and you will be using the formula V minus U by T to get the required answer. But you have to do some numericals at your own, and for that I want you to learn a concept. Children, if it is written that the body is starting from rest, the body is starting from rest. Whenever this is written, it means its initial velocity is 0 meters per second. If the body is starting from rest, means its initial velocity is 0. Learn this. I'll ask you in the class also. You have to answer me these two parts. Second part is, if body is made to stop, or sometimes it is written if the body is brought to rest, that means it was already moving and you have applied brakes to bring it to rest. That means its final velocity will be taken to be 0 meters per second. So if the body is at rest, initial velocity is 0. If it is brought to rest, then final velocity is 0. So learn this concept, and further with this I come to an end of this interactive session. You are supposed to do numerical number 9, 10, 11 and 14 in your physics notebook. Thank you, students, and have a nice day, please.